Hello, today I will be speaking about the potential of using neural networking and algorithms to revise a nonprofit organization distribution process. Specifically, the example I will use is with a food bank. Food banks have become increasingly important. In 2020, both the provincial and federal governments pledged to give money to support the food banks, largely due to the impact of COVID. Despite its importance, we've also heard about how food items are not nutritious enough or are past their best before date, or if food is even available. There are also examples where not enough consideration was made and the wrong food is sometimes given to the users. Today, we will answer the question of how these problems might be addressed through a neural network model. The goal of a food bank is to store and distribute nutritious food and to give its users sustained access to such food. They accept and solicit food donations from a variety of sources, such as private donors, food drives, supermarkets, retailers, and restaurants. Food banks provide a few days of supplemental food at no cost. They are characterized as short-term benevolent response to help individuals get back on their feet in times of hardship. As an emergency food provider, the duration of a difficult time is not defined, but it is supporting immediate needs. Food banks typically apply eligibility criteria, such as income, residence, location, and other sources of income or assets. They are used to review people's requests for assistance and to place restrictions on the amount and selection of food, and to determine the frequency the user can receive assistance. These criteria are used as constraints which limit the amounts of food given in order to ensure demand is consistent with supply. Additional restrictions are sometimes necessary to prevent the agency from running out of food, including limiting the variety of food, reducing the size of hamper, prioritizing clients, reducing hours of operation, and turning people away. In a study of 5 major Canadian food banks, it was found that 2 predictors of a food bank success are the proportion of food donated and the number of volunteers working. There is an equilibrium of supply and demand that a food bank must maintain. If a food bank tries to meet all the needs in the community, they will have more trouble maintaining services. The solution is to create tactical restrictions, often to do with the frequency and schedule of service. They must employ restrictions. If they don't, they will run out of food. Food banks are donor-driven, affecting both the quality and quantity of food distributed, with donations often being insufficient or having poor nutritional values. It is heavily reliant on donations and volunteers, and they have a limited capacity to respond to those seeking assistance. In a 2018 study examining food bank usages in Vancouver, found that one large food bank in a period of 25 years, 117,000 individuals made more than 2 million visits. The majority were short-term users, but 9% were long-term, ongoing users and constituted 65% of the visits. Users tend to experience long and cyclical periods of poverty, low income, unemployment, adverse life effects, and or health challenges. Seniors that do use food banks are challenged by fixed income, rising food, shelter, and medical costs. Food bank users are not necessarily food insecure, and the reverse is true as well. It is important to note that food bank users, as a distinctive client base, sometimes differ from those who suffer from food insecurity. Instead, a 2015 study found that those who use food banks depends on the severity of the individual household and the accessibility of food bank services. So with what is often an insufficient supply of high quality and quantity of food donations, how do we ensure severe needs and special needs are satisfied? A qualified need user is defined as a person who does not have many resources for food, who often experiences hunger and has more than one factor causing them to be food insecure. A qualified need user is sometimes someone who would perish or suffer without food programs. They are the people the program was envisioned to serve and whom the organization markets themselves as doing good for. They are users who conform to the standards and expectations of the experiences that can cause one to need a food bank hamper. When we model the distribution of food using a neural network model, we will use a wide abstract definition of a qualified need user and then narrow it down to variables based on their specific self-reported needs. So what is neural network? What is a neural network? How are algorithms used in deep learning? Neural networks are modeled after a biological brain neuron. A neuron has the input and output points. It processes the input according to instructions provided by an algorithm. An algorithm is a set of instructions used to program each neuron or group of neurons with a function in a distribution. In between are one or more layers, and deep learning occurs when input is passed back and forth throughout the network. Options for neural functions include and/or, true/false, threshold, and step. For modeling, we first need to clarify a few concepts. A qualified user is conceptualized as households that have various levels of needs for a food bank hamper and is defined through passing thresholds and accumulating weighted scores. Variables are age, employment status, location, if they receive social assistance. Variables are binary, such as yes is a 1, no is a 0, to simplify the data collection. Weight combinations is determined by the decision maker and is the result of the food bank's distribution policy. We use a base case with estimated parameters to get initial results and repeatedly adjust them as needed. The type of functions in neurons include and/or, true/false, threshold, step, and storage. Architectural design is a cyclic, feed-forward, and module units. I have chosen an unsupervised learning models, which means we can 1. Adjust the demand using sum of square errors. 2. Detect features by activating functions and weights. 3. Cluster or layer data. And 4. Combining neural networks with other agencies to create a learning system. Some important points worth noting. There are privacy and ethical regulations regarding the use of personal information in algorithmic decision-making. So we're not using any personally identifiable data and then collecting data only for program improvement. Model 1. To get an estimate of the number of food hampers to prepare, we must ask users to self-identify as belonging as to one of these categories: elderly, single parent, family, individuals. These groupings are commonly applied by food banks to describe their users. We create an estimate of the total needed per group. We then pass out hamper based on their group. Each week, we calculate the difference from our estimated to the reality. We do this calculation each week as we pass hampers out. After a period of 10 weeks, we calculate how much is the difference from our estimate to the total to get the sample standard error. Last, we reconfigure each group hamper total to that corrected by the standard error. If the conditions are the same, that should bring the difference down to 0. If not, we can continue to readjust until the error is an acceptable level. For example, less than 5. Thresholds for adjustment process can be determined by the decision maker. Model 2. We have already asked whether age, location, income as descriptive variables applies to them. This is based on the questions asked to the users and their own report about their own situation. To qualify for a food bank hamper, a person must have at least a score of 1 to qualify. The other criteria will be noted down with binary digits to make it easy and fast to record, such as 1 equals yes, 0 equals no. We collect the total sum from each of these criteria. We now create a scale, and here is where a decision maker will need to set thresholds. Here I have set high needs as greater than 4, medium need as 2 or greater, and 1 or 0 as low need. Next, after collecting and summarizing all the 1 and 0s, we can now graphically summarize the data from this exercise. As an example, here's a summary of all the users in the cohort or category. 60% of seniors receiving food bank hampers lived within the catchment area. 40% were also challenged by disability, and 50% were still working part-time. This is an example of the data you can pull out of a network. Model 3. In this model, we start to lay out the proposed network while incorporating the context. We start with the input of the suppliers from 3 groups of suppliers, which creates a storage and inventory of food to pull from. Food bank communicates to the agents to get the food they need, and the agents brings back the food to the food bank. The number of hampers prepared will have been tested from the first model and calibrated to produce hampers with the lowest margin of errors. We'll then start with activating the eligibility functions, which is just information for us whether they qualify to receive the food bank hampers. This uses the true-false function, keeping in mind that the score of 1 is the minimum to get served. If they have this, they are pushed forward. If not, they are turned away. Then we look at the level of need based on their scores using a threshold function, where if they are high need, that is if they have 5 or more yeses, or medium needs if they have 3 or more yeses, and low need if they have 1 or none. High need would get a full hamper, medium need would get a medium hamper, and similarly a small hamper would be given to those who have low scores. For now, we can see that for our seniors, a large portion, 50%, received medium hampers due to the low level of needs. Similarly, 50% of families with children received large hampers corresponding with a high level of need. 57% of single parents also required a large hamper. Model 4. In this final model, we will consider if and how we can accommodate users that have specific needs and preferences. These are people who have food allergies, dietary restrictions, religious or ethnic food preferences. Each of these will be given a weight of 0.25 if it applies. First, the category of specific needs or preferences will remove any items not suitable for the client based on research or feedback. The items will be removed. Next, using the AND/OR function, the inappropriate item will be replaced if something is available. These middle layers will store information about appropriate food items or options for age, ethnic, religious, and dietary preferences. The item will be replaced in the appropriate item if it is available. Whether action was taken at this stage will be recorded, and the hamper is finally outputted. Once again, we focus on the senior users. In this sample, we granted concessions to 23% of users and were not able to give concessions to 54%. Of the 23% we were able to make a change to the hamper, 17% we removed items only, and we were unable to place items for 6%. To sum up, for our results and explanations, we have defined what a qualified need user is and the type of users they may be grouped into. This is also where we start our input. Values are imbued throughout each step in the form of weights or biases. Constraints is included, incorporating the importance of supply and demand, and are hinted at where we can only remove or replace items in a hamper for people with sensitive needs, but not exceed that. We have information about what replacement for each group may occur should we wish to accommodate them, but it is only based on the availability of food. Other results and outcomes. One of these is the clear criteria and rules for decision making. It may also be easier for volunteers and staff to implement the program. It can also reduce cognitive biases, that is, tendency to draw conclusions or adapt beliefs without insufficient or rational evidence to support it. It also allows the program to be regularly evaluated and revised during program operation and at different points. And of course, it is data-driven. Here are some steps you can take when creating your own neural network. First, step 1, assess the goal and the purpose of your network. Step 2, start with the highest aspirational goal and work backwards to specific objectives. Step 3, match blocks of people with a service, such as people with food supplies. There's determined functions for neurons, or nodes, determines bias and weights, which usually depends on the organization's values and decision makers. When you get to the end, realize that it is the end of your conceptualization of a virtual network, and that it will be reviewed and revised in the context of the community. Some limitations of this approach are, it depends heavily on the type of service if it makes sense. For example, it would be inappropriate for it to be used for a program for addiction treatment. In order for it to be implemented, it must be tried in real time and tested over and over again. It is also important to link it to a higher level policy to have it accepted and sustained. So when you have finished testing and implementing as much as possible, evaluate how it went and why. Realize that the greatest risk is for this model, when applied, to become stiff and inflexible. I believe this will result in causing more problems than it solves. It should always be with changing and evolving with the context and program needs. To conclude, food banks, with the distribution policies and operation requirements, make them a suitable charity or agency to use for the neural networking model and deep learning model. There will be other short-term urgent service agencies or charities that can benefit from this. Here are some of the notes about food banks that I found helpful in putting together this presentation. Remember to like and subscribe, and have a great day.